Hello everyone. Today we are here for the post-contest discussion of Codechef Starters 147. So, let's start with the discussion. What's your doubt, Ayush? Let me allow you to. Yes. What's your doubt?
Sir, I just need to ask that are we going to discuss problem E in Div 2? Right?
We are going to discuss 5 problems. I told before.
Okay, sorry.
Okay. Yeah. So let's. So let's start with the discussion. So this is the first problem. The name of the problem is Gold Coins 101. So Chef and Chefina are competing against each other in a football game where the player scoring the maximum goals wins. So it is known that the winner of the game receives A gold coins while the loser receives only B gold coins. So given that Chef scored X goals and Chefina scored Y goals, and it's given that X is not equal to Y, you need to find out the number of coins Chef would receive. So you are given an inputs B, A, B, X and Y, and the winner is getting A coins, the loser is getting B coins, Chef is scoring X goals, Chefina is scoring Y goals. So you need to tell that how many gold coins would Chef receive. So like if I take a very simple example, so if I take this example, if the values of A, B, X and Y given to you are something like this, 10, 6, is there any constant in that? 10, 6, yeah, okay. 10, 6, and let's suppose 3 and 4. So Chef is scoring 3 goals, Chefina is scoring 4 goals. So how many gold coins would Chef receive? The loser is getting 6 gold coins and the winner is getting 10 gold coins. So you can see that since Chef is scoring lesser number of goals as comparison to Chefina, so Chef will get 6 gold coins. Similarly, if example was something like this, let's suppose 4 and 1. So over here you can see that Chef is scoring 4 goals, Chefina is scoring 1 goal. So basically Chef is winning the game and it's given that winner is getting 10 gold coins. So in this case, Chef would have received 10 gold coins. So this is the question. Is the question clear? Anyone having any doubt in the question? I am guessing no. Okay. So the thing is clear that the winner is getting A amount of gold coins and the loser is getting B amount of gold coins. So how we can determine that whether a chef is a winner or a loser? By just comparing its goal with Chefina. So if Chef is scoring more number of goals than Chefina, we say that Chef is a winner and we will award him A gold coins. And if Chef scores lesser number of goals as compared to Chefina, in that case, Chef is a loser and we will award him B gold coins. So that's the simple logic for this problem. Anyone having any doubt? Anyone having doubt in this question? Let me show you all the implementation. So you are taking A, B, X, and Y as inputs. Then if X is greater than Y, that is Chef is scoring more number of goals as compared to Chefina. This means the Chef is winning the game and the winner is getting A gold coins. So we are simply printing A. And if this is not the case, that is X is lesser than Y, this means that Chef is a loser and loser is awarded B gold coins. So we are printing B. So that's the simple code for this question. Anyone have any doubt in this question, or should we jump on to the next one? Next. Okay. So the next question is this: Independence Day 101. So on the occasion of Independence Day, Chef wants to design a new flag for the country of Chefland. Now he has some equal sized strips in 3 different colors and needs to arrange them in the line so that no 2 adjacent strips share the same color. So given that Chef has A orange strips, B white strips, and C green strips, you need to determine if it is possible to design such a flag using all the strips. So first of all, let's understand what the question wants to say. So in the question, you are given strips of 3 different colors. So there are A strips of orange color, B strips of white color, and C strips of green color. Am I right? Is this something that is given? C of green, B of white, and A of orange. Now, what the person wants it, what the chef wants it, is that he wants to arrange these strips in a single line such that no two strips of same color comes adjacent to each other. Like for example, if I say you that the value of A is 5, that is you have 5 orange strips, the value of B is 4, and the value of C is 3. If I say you something like this, so one possible combination would be that you keep these 5 A's and then you keep something like this: B, 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 C, then B, and then C, and then C. So this is one of the possible combination where you have kept 5 A's, 4 B's, and 3 C's, and no strips of same color comes adjacent to each other. See, you don't have something like this A or B or C. There are no two strips of same color coming adjacent to each other. So if there is something, if there is a combination something like this, you can arrange these flags of these colors something like this, then the answer would be yes. Else the answer would always be no. So this is the question. Do everyone understand the question? Anyone having any doubt in the question? Just let me know. No doubt. Okay. So how would we solve this? So one thing that came to my mind while I was giving the contest was that, okay, we have three values A, B, and C. Then what I did was I took maximum of, yeah, something like that. I took maximum of these values. Okay. I took maximum of these values. So let's suppose I take some values. So let's suppose I take A as 5, B as 3, and C as 1. Okay. I took maximum of these values. It was 5. So what I did was I kept 5 A's, something like this. I kept 5 A's. Now what I know is, now tell me what is the minimum sum of B and C you need? Minimum sum of B plus C required. I am assuming that A is the maximum value. Any one of these three can be maximum. Over here I have told that okay, A is the maximum. It is having the value 5. Now just tell me what is the minimum sum of B plus C required and why? I know that I can't keep all these A's adjacent, right? So I have to put some values over here in between. So the minimum sum of B and C required is 4. Minimum sum required is equals to 4. Do everyone agree with this? Or anyone is having any doubt? Assuming that A is the maximum value. So if the value, like in the example I took, if the value of A is 5, so in this case, the minimum value required is 4. Similarly, if I generalize this, the maximum value, if it is X, so the minimum value of B plus C you require is X minus 1. Do everyone agree? Till now, any doubt? Okay. So now what I claim is that if I have minimum of B plus C greater than equals to X minus 1, my answer will always be yes. Why I say this? What's the intuition? The intuition is that I took the maximum value. First of all, I placed, like, let's suppose A was 5. So I placed 5 A's right over here. So now I know that the minimum values of B plus C, that is the rest two values that are left behind, the minimum values of them required would be 4, because I can't keep all the A's together, any A together. So I have to insert some element in between every A. So now I know that I have to keep at least like 5 A's, something like this. So I have to keep at least 4 elements. I need to have at least 4 elements. Now what I know is that every element is lesser than equals to 5. This is something that I already know. That every element, that because I know that A was the maximum element, A was 5. A was the maximum element. So every remaining element B and C is lesser than equals to 5. So I can always place a permutation something like this: BC, 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 something like this. I can always do the something like this. What I told, I repeat. Let me repeat. I say that there are three values. Let's suppose the maximum of these values is A. So let's suppose I took A as 5. So I placed 5 A's. Now, what is the maximum value of B you can have? Maximum B that you can have. Tell me. What is the maximum B that you can have? If I say that out of A, B, C, A is the maximum and it is having value 5. So what is the maximum B that you can have? Maximum value of B that you can have? 5, right? Because if B is greater than 5, then the maximum of A, B, C would never be 5, isn't it? So the maximum B that you can have is 5. So you can always place 5 B's, something like this. You can always do this. And similarly, what is the maximum C that you can have? Again 5. So again, you can always place something like this. So what I claim is that if I am having some maximum value, let's suppose maximum value is A. So the sum of remaining two values must be at least A minus 1. Because if it is not A minus 1, we cannot place A's such that no two A's are adjacent. So at least I require that sum of B and C should be at least A minus 1. If it satisfies this, so I know that the answer will always be yes by looking at this particular example. By looking at this particular example, we can always say that the answer will always be yes. Do everyone agree? I am allowing you all to unmute. Just let me know if anyone has any doubt. Do anyone have any doubt? Kindly let me know. This was actually the intuition for this question. No doubt? Great. So let me jump on to the code. So the code is, first of all, took three values and then found out the maximum value, stored it in temp. To get the remaining three values, I shorted the vector. So implementation completely depends on you. So you can do it in the any way you want. So first of all, I found the maximum value in the vector. Then I got the sum of remaining two values. So how to get the sum of the remaining two values? So what I did is I sorted this vector V and got the sum of first two values. So I know that if I am sorting it, so the first two values will be the values that I'm not considering as maximum, because V of 2 is the maximum value. So V of 0 and V of 1 are the remaining two values. So if the sum of these value is lesser than temp minus 1, because temp was the maximum value. So if it is lesser than temp minus 1, so my answer will be no. Otherwise, my answer will always be yes. So implementation again depends completely on you, but the logic remains the same as we discussed in our slides. Any doubt? Anyone having any doubt? Should I move on to the next question? 74th line. So over here, I am just declaring, okay. So this is something that is not needed. This is something that is not needed. Actually, during the coding, I kept three variables. I was taking input for ABC, but because I required this thing, so I then took the values in vector. So this line you can neglect. So you have vector of size 3 and then you are taking the values in input in the vector for the three values. Is it clear? You don't require this line. Yeah, you are taking the values input in the vector. So again, you can do it by the way you want, but I have done it by taking the values in the vector and then shorting the vector and something like this. 77th line. So this is a syntax for getting the maximum value of a vector. Star max element, all V. All I have defined as a template. So all V means V dot begin, comma V dot end. So this is actually a syntax to get the maximum value in a vector. So you can anyways write like this as well. Like what you can do is you can remove this line. You can take the input and you know that the maximum value is V of 2. So you can replace this term by V of 2 as well. This is also something that is allowed. Is this thing clear? Anyone having any doubt in this? V of 2 is the maximum value. Since we shorted the vector, all V means V dot begin, comma V dot end. This is something that is defined in my template. Okay. Anyone else having any other doubt, or should I move? All clear, guys? This type of arrangement logic is enough. All clear. Okay. So let's move on to the next question. Okay. So the name of the question is Truth Teller and Liars 101. So you are a traveler and you are at a junction of two paths. One leads to eternal happiness and the other to certain doom. Okay. So there are a total of n plus m people, n of which who always tells the truth, while the remaining m may tell the truth or lie. So you can't believe on these m persons. So all of them are aware of which path leads to where. So all of them are aware that which path will lead to you to eternal happiness and which path will lead you to doom. So you don't know who is a truth teller and who is not. So you will ask some randomly chosen X people the following question: that which among the two paths leads to eternal happiness? Okay, so you will randomly choose X people and ask this question. So the problem is it possible for you to be sure which path leads to eternal happiness? And if it is possible, then you need to find out the minimal X where you can sure of the path, regardless of which X you end up asking. Otherwise, you print simple -1. Okay. So it's a very basic implementation of pigeonhole principle. And even if you don't know pigeonhole principle, it's like actually a common sense question. Let me tell you why. First of all, let's understand the question. So in the question, what you are given is you are given X people who will all there you are given, let's suppose, N people who will always tell the truth, and there are M people who always tell lies. Okay, we know this. So now you are randomly choosing X people and you are randomly choosing X people and going to each one of them and just asking, just tell me which path will lead me to eternal happiness. So you want to choose a path of eternal happiness and you will go and ask each of these X person that which path will lead to eternal happiness. So now out of these X people, what is the worst case? Like let's suppose these X is greater than equals to M. What is the worst case? Like let's not take X greater than equals to M. Let's take X is less than equals to M. What is the worst case? Worst case is that every X people will tell lie. This is the worst case. Can I say this? If you are choosing X people at random and X is less than equals to M, so in the worst case, it is possible that you chose this X people from this set of M peoples only, from this set of M people only. So it's always possible that all these X person tell you lie. Is it possible in the worst case? Like if I say you that there are 4 people who is telling truth and there are 6 people who are telling lies. Now you randomly chose 5 people. So in the worst case, it is possible that all of these 5 people belong to this set of people who always tell lies. That is a possibility, right? So if that is the case, you will never be able to reach to eternal happiness. Now, if you randomly chose, let's suppose 6 people. So just tell me, what in the worst case, how many people will tell you lie? In the worst case, 6 will tell you lie. If I randomly chose 7 people, the value of X is 7. How many people will tell me lie? 6. Similarly, if I chose, let's suppose 12 people, how many people will tell me lie? 6. So, what conclusion we are getting? That, okay, if I am choosing 12 people at least, if I am choosing 12 people at least, I will get 6 people who are telling me lie. So, now if I choose 13th person, if I choose 13th person, so even if, so what is the maximum number of people who will tell me, maximum number of persons who can tell me lie? Just tell me. If I'm choosing 13%, there are 6 persons who will tell me lie. So 7 persons, 7 people will tell me the correct path. So if I choose at least 13 people, I will always lead to the correct path. Something like this, that these 6 people, let's suppose there are two paths A and B. A is a path of happiness and B is a path of doom. So this 6 people will tell me go to B. And this 7 people, since they always tell truth, so they will tell me that go to A. So I will go to A because majority says A. So if I am choosing 13 people, so I will always lead to the correct path. Do everyone agree? Yes. So from where did this 13 came? From where did this 13 came? 13%. See, there are M people who are always telling lies. So to balance this M people, I require at least more M people, isn't it? Because this M people will tell me always lie. So if let's suppose the path that I should go is A, so they will always tell me B. So now the more M people will tell me A. The more M people who always tell truth will tell me A. But at this point of time, I am pretty much confused because M people told me B, M people told me A. So I don't know where to go. So I need to take at least one more person who tells the truth. So if I take at least one more person who tells the truth, so I can guarantee that I will always lead to the correct path. So can I say that I want at least 2m plus 1 people? Can I say this? Do anyone have any doubt in this? Just tell me. Do anyone have any doubt? Explain the logic. Okay. See, there are n people who always say truth, and there are m people who always lies. Okay. So I am randomly choosing x people, and I want to guarantee that I always go to the correct path. So let me assume that the correct path is A. There is a path named A. It is a correct path, and B is the wrong path. So in the worst case, what would happen? That the x random people that I am choosing, of them, m are the ones who always tell lie. Who always tell lie. So these m people will tell me, hey, come and go to B. Now, if I go to B, if I listen them and go to B, I will go to the wrong path. That is something I don't want. So M people told me that go to B. Now, once I am done choosing from these M people, the remaining person will always tell the truth. I chose X people. X is greater than M, and X of these X, M were the ones who always tell lie. So the remaining ones will always tell truth, isn't it? So the remaining ones will tell me that, okay, go to A. But how many of at least these people I need who will tell me go to A? How many of these at least people I need? M plus 1, isn't it? Because M people already told me B. So once I get A in majority, then only I will start going to A because I will listen to majority of people. What majority are saying. So I will need at least M plus 1 people telling me that go to A. So how many minimum persons I need? M plus 1. That is basically 2m plus 1. Of these, m are the ones who always tell lie, and m plus 1 are the ones who always tell truth. Is it
So
clear now?
m what if 2m plus 1 value is greater than that of n plus n, sir?
Sorry,
What
can
if
you
if 2m plus 1 value is greater than n plus n, sir?
m plus
Let's
1
say,
value is greater than 2m plus 1 value is greater than n
yes,
plus m. This is you are asking.
yes, sir.
Yeah,
Exactly.
if this is the case, the answer will be minus 1. You can't guarantee by choosing x random people. It's mentioned in the question that if it is
Yes,
not
sir.
possible to find minimal x where you can be sure of path regardless of which x people you end up asking, so you print minus 1.
Okay, sir.
Okay. So you just observe one thing, that we are choosing m people who always tell lie and m plus 1 people who always tell truth. So if I am able to choose m plus 1 people out of n people, because there were n people who were always telling truth. So if I am able to choose m plus 1 out of n, so I should be guaranteed that n should always be greater than n. Then only I can do this. Otherwise, I can't do this. So my code will be simple that if n is greater than m, then my answer will be 2m plus 1. Else my answer will always be minus 1. Is n less than m? No. If n is less than equal to m, then we should return minus 1. Because to balance m people who tell lie, I need at least m people, m plus 1 people who tell truth. So let's jump on to the code. So basically took inputs of n and m, just neglect this line. So if n is greater than m, then in that case my answer will be 2 into m plus 1. Else my answer will be minus 1. That's the simple logic. Because we are considering the worst case, that out of the random x people we are choosing, let's suppose we get m people who always tell lies. So to balance those m people, I require at least m plus 1 people who tell truth. Then only the majority will be telling truth and I will go to the correct path. So at least you require 2m plus 1 people. Is it clear for everyone? Should I move on to the next question? Next. Okay. Just let me know. Do anyone have any doubt?
Sir, no doubt.
Okay. No doubt, right? Okay. So moving on to the next one. So non-primes 101. So you are given an array A of size n. You need to find pair of indices I comma j such that ai plus aj is not prime. In case multiple I comma j pairs are valid, you may print any one. And if it isn't impossible to find such I comma j, simply output minus 1. So there is a definition given for prime numbers. Do everyone know what are prime numbers? Do everyone know what are prime numbers? Do anyone overhead who don't know what are prime numbers? Okay. So assuming all of you knows what are prime numbers. Okay. So first of all, let's understand what the question wants to say. So in the question, you are given n integers. You are given n integers and the values of n integers, and you want to say that can you take any two integers in this array, add them, and obtain a number that is not prime. If it is possible, so if this is index I and this is index j in one based indexing format, then simply output I and j. Simply do this. If there is no such I comma j, such that when you add ai and aj and you get a non-prime number, if there is no such I comma j, then simply output minus 1. Like if I take this example, 1, 2, 3, 4. So taking this example 1, 2, 3, 4. So over here I can always add this two numbers and their sum will be 4, which is a non-prime number. So I can always output index 1 and index 3. So index 1 and 3. But if I take this particular test case 1, 1, 2, 1, 1, 2. So in these, what are the pairs? So possible pairs are 1 plus 1 or 1 plus 2. So in both the cases, these numbers are prime numbers. If I add these and these, or these and these, if I add any two numbers, so the sum will always be a prime number. So I can't take any two pairs which have the say which on addition of their values give a non-prime number. So my answer in this test case would be minus 1. So this is the question for you. Do everyone understand the question? Anyone having any doubt in question? What the question wants us to print? No. So how we can solve this question? So the explanation of this question is actually becomes very easy because of the constraints of the question. So if you just look up the value of AI in the array, it is maximum 100. Okay, so it is maximum 100. So when I tell you that I am adding two values of this array, AI and AJ, what is the maximum value of these? What is the maximum value this value can be, AI plus AJ? Can someone tell me? What is the maximum value this AI plus AJ can be? It is 200 because the maximum value of any AI is 100. Okay, so this maximum value is 200. So then I thought that if I do something like this, that find all non-prime numbers from 1 to 200. If I do so, if I find all non-prime numbers from 1 to 200 and store them in some map. Okay, store in them in some map or vector, something like this, anything you can use. So store them somewhere. So let's suppose I am using a vector. And in my vector, I stored all non-prime numbers. Now, if I am coming to any number AI, what I want to check? I want to check that if I take this particular number, so is there any other number towards the left of this? What I am doing is I am going to any index I and I am checking, does there exist any number towards the left of this particular number, which on addition to this particular number gives me a non-prime number? Is the task clear? What I am trying to do? What I am trying to do is I am talking of any index I. For this particular index I, what I am trying to do is I am trying to check, does there exist any number towards the left of this index I, which when added with a of I, gives me a non-prime number. If there exists any such number, so simply print the index of that number and this particular I, and the job is done. Do everyone agree with me in this? Do everyone agree with me in this? What I'm trying to do? You don't require C's. I will come to that. Without using nested. Do you, Sacker, do you understand what I'm doing or what I want over here? Or is it not clear? I told that if I am at a particular index I want to check, does there exist any number towards the left of this index I, which on addition with AI gives me a non-prime number? Is the task clear?
Okay, now if I'm not able to find that number, then what will I do next? I'll have to
I will move on
increment
to
or
the next
decrement it,
index.
right?
I will simply keep on incrementing my I, and if
So
till the end,
that won't be a nested loop.
no, I am coming to that. I will not do it in nested loop, but just tell me, is the task clear? If I will
Yeah,
go and do it for every I, and if I don't get an answer, so I will print -1. So
yeah,
is the task clear? Okay. So now the only thing that remain for us is that how to check that for a particular AI, I have an index towards its left or not. That is, that when on addition with AI give me a non-prime number. This is the only task that is remaining, isn't it? So to do this, what I did is, while I was moving from left to right, I was storing the indices of all the numbers in this array towards the left in a map. Okay. So let's suppose I had this 1, 2, 2, 3, 1, something like this. So while I am over here, while my I is over here, so what I did is in my map, I have the index of 1 as 0, if I consider 0 based indexing. So index of 1 is 0 and index of 2 is the latest index that has come. So index of 2 is 2. So I have this thing stored in my map. Okay. Now for 3, how to check that do I have any number towards this left or not, which on addition with 3 gives me a non-composite number. So what I do, I go to each possible composite number. I have already stored all the possible composite number. I go to each possible composite number. So what are the possible composite numbers I have? The possible composite numbers I have is 1, 4, 6, 8, 10, 12, and up to 200. Up to 200, I have stored all the possible composite numbers. So now what I will do is I will go to each possible composite number and I will check that can I construct that composite number. So first of all, I will go to 1. So I will check, can I construct 1 by using 3 or any of these numbers? How can I check that? If I want to construct 1 on addition to some 3, I want to add some number x to 3 and I want to get 1. What should be the value of x? It should be -2, isn't it? So I will simply check, do my map contains -2? I will get no, my map does not contain -2. So I will answer that, okay, I can't construct composite number 1. I will move on to the next composite number. I will go to 4. So I will check, can I construct 4? This means that I will add something to 3. I will get 4. This means something that I want to add should be 4 minus 3. That is equal to 1. Do I have 1 before this element 3? Map will tell me, yes, you have that at index 0. So I will say that, okay. So I can construct a composite number by adding 3 to some number. So I will simply answer the index of 1, that is 0, and index of 3, that is I, and the job is done. Now, why I am able to do this? This is because the number of composite numbers will be lesser than 200. So even if I run a loop of this 200 for every I will get a time complexity of n into 200, which will never produce TLE. So that's the reason this can be done. Is the logic clear to everyone? Should I repeat?
Can you repeat this?
Yes, I can. See, first of all, was it clear till then that I will go to index I and I will look for some numbers in the left of this index I, that if that particular number and this on addition with 3 gives me a composite number or not, non-prime number or not. I will check that. Was the logic clear till then? The one who had the doubt, was the logic clear till then?
Yeah, can you repeat, sir?
That part also. I told that what I will do is I will go to each particular index I and take this I as one of my numbers. I have to take two numbers, AI and AJ. So let me take this as one of my numbers. So I will simply check that does there exist any number towards this left of AI which I can take, so that which is present at any index j. So I can take this and AI plus AJ is equal to composite number. I will try to do this. I will try to take
Okay, sir.
Sorry?
Sir, okay, sir. So next, sir.
Yes. So I will try to do this. So how I can do this, that I have this value AI. So I will go to each possible composite number, because this AI plus AJ, when added, they will produce some composite number. And I already have this vector where I have stored all the possible composite numbers, since I know that the values AI and AJ at max can be 100. So the maximum composite number they can produce on addition is 200. So I have already stored all the composite numbers from 1 to 200. Now I will go to each and every possible composite number and check that can this composite number be produced or not. So like the example I took over here, that till in my vector, I am at this particular index. So my map MP of 1 contains 0. That is MP of 1 contains, let's suppose 1, the latest index of 1, and MP of 2 contains 2. That is 2 is present at index 2, 1 is present at index 1. Now I am at 3. And I have the vector of composite numbers with me. So these are the composite number vectors that I have: 1, 4, 6, 8, 10, 9, 10. These are composite numbers, right? Up to 200. I have these stored in my vector. So I will go to each and every composite number and check that whether it can be produced by the summation of this number and any number towards the left of this number or not. So first of all, I will go to 1. Now to produce 1, I will add something to 3. this something lies towards the left of 3. I will add something to 3 and produce 1. So in this case, this something should be 1 minus 3, that is equals to minus 2. But my map tells me that I don't have any number that is equal to minus 2 in my array towards the left. So I will tell that, okay, I can't produce 1. I will go to the next composite number now, that is 4. I will try to check that can I produce 4. So I will check that if something added to this number 3, if it produces 4, so this number should be 1. That is 4 minus 3, 1. So I want to check that does there exist element 1 in the map. So map will tell me yes, I have 1 stored. So this means that 1 has come to the left of this 3. So I will simply take the index of that particular 1, index of 3, and output that in my answer.
Yes, sir. Understood, sir.
Okay.
Sir, is it like a two-sum approach?
No, it is not similar to two-sum approach, but it's a very common example of like uh, something like this, that whenever we require to find some sum by taking a particular index, so what we do is we simply check that sum minus this particular number is present in the map in the array before or not.
Yes, sir.
And to do
Yes,
that,
sir.
we
Okay.
simply maintain map. Map help us to do that in big O of log n time. So that is really helpful, isn't it? Because
Yes, sir. Okay.
if we don't have map, then we need to simply traverse a J loop from I minus 1 to 0, and that will again produce TLE. That is big O of n square approach, isn't
Yes,
it?
sir. Okay, sir. Thank you, sir.
And why we are able to do this? Because we know that the maximum number of composite numbers will anyways be 200. No, lesser than 200 it will be, but in like assuming it, the maximum can be 200. So I can check that whether for every index I can check that whether this particular composite number can be created or not. Agree? Anyone having any doubt? Should I jump onto the code? Okay. So moving on to the code. So first of all, took the input of n, then took input of n numbers, constructed the map, and added 0th element in my map. So MP of V of 0 is equals to 0. Now I am going to each and every number. So first of all, before doing this, just come over here where I took test cases as input. Then I have constructed a vector B. Okay, vector B. And in my B, I am pushing all the composite numbers. So first of all, I pushed back 1. Okay. Then I am going to each and every number from 3 to 200, and I am checking that how many divisors this particular number I has. So I'm going to each and every number from 3 to 200 and checking how many divisors it has. So this is a very common practice of checking the total number of divisors, because if this particular number I has even a single divisor from 2 to I minus 1, so I can clearly say that that particular number is not a prime number. So I simply ran a loop of j from 2, j into j less than equals to I, j plus plus, because square root of I gives us till, if we run our j loop till square root of I will get all the possible divisors. This is a very common practice. So I would recommend you all to see how we can get the divisors of a number. So this is a very common practice. So if j divides I can guarantee, I will simply increment the value of count. That is okay. I have got a divisor of I. At the end, if my count is greater than 0, this means that I has at least one divisor that lies from 2 to I minus 1. So in my B, I will simply push back I, because I is now a composite number. So since vector B stores all the composite number, so in my B, I will push back I. So now this method of finding all the composite number completely depends on you, how you want to find all your composite number. But once you have your composite number vectors, that is a vector storing all the composite number, what you will do is you will go to each and every index I and simply check that whether can you produce that particular composite number or not. So you will go to each and every number in the composite number vector and simply check that does your map contains IT minus V of I or not. So you are standing at ith index, so your value is V of I. You want to add some value and produce IT. IT is actually a number in the vector of composite number. So this X is nothing but IT minus V of I. So I will check that does my map contains IT minus V of I? What is the syntax? mp dot find it minus v of I is not equals to mp dot n. If that is the case, so whatever is the index of it minus v of I and this particular index I forms a valid pair. So since I need to output the answers in one based indexing format, what I did is mp of it minus v of I plus 1 and I plus 1 and simply return from here because I have got a valid pair. Once I'm done with this for this particular index, what I did, I simply added this particular number in my map. So I simply updated mp of v of I as I. Once I am done with this and still now I have not returned, this means that I have not got even a single valid pair. So in that case, I simply output -1. So time complexity is actually n into 200 into log n. So n log n into 200, you can say something like that. But it will be lesser than 200, n log n, it will not be multiplied by 200. Actually, the total number of composite numbers. So you can think of like that. So the time complexity will be n. You're going to each and every index. For every index, you are traversing the, you are using map. So log n multiplied by, you are traversing the vector of composite numbers. So that the size of composite numbers vector. So let's suppose at max it will be 200. So this will be the time complexity. Okay. So is the approach clear to everyone? Should we move on to the next question? Calculate no, can calculate a not prime in 1 to n and then use to sum. What about this? Yeah, there can be multiple ways of implementation, but the logic remains the same. Isn't it? What you can also do is you can put all the numbers in the map at once only and then check for every number. That is also a possibility. So implementation is completely something that depends on you, but the logic was that we will go to each and every number and then we will check that if out of two numbers, that ith index number is one of my numbers. So can I get the second number which on addition with this ith number give me a composite number? So this is the logic. So for that, you need to go to each and every possible composite number and check that whether you can produce that possible composite number or not using this ith index number. So if yes, simply print those. Otherwise, -1. Okay. So should we move on to the next question or anyone have any doubt? Let's move on. Okay. So this is the last question for today. So this is the question. Case of sequence 101. So let B be an array of size m. We defined f of b as summation of bi plus 1 from I equals to 1 to m minus 1. So this is a function, this is a definition of function f. So now you are given an array A of size n and an integer k. You need to find the maximum value of f of c where c denotes the k-sized subsequence of array A. So what is the question? The question is that first of all, you have been given some function f. So if you apply this function f to some any array B, so let's suppose array B contains 5 elements, B1, B2, B3, B4, B5, then f of B is nothing but B1 plus B2 plus B2 plus B3 plus B3 plus B4 plus B4 plus B5. This is f of B. That is f of B is nothing but summation of Bi and Bi plus 1, where I range from 1 to m minus 1, where m is the size of B. Do everyone understand what is this function f? what this function f is calculating. Do anyone have any doubt in that? Okay. So once you understand that what this function f is doing, so the question says that you are given an array A that contains n integers. Now out of this array A, you are choosing k elements from this as a subsequence. This k elements are subsequence of A, and using these k elements, you are constructing another array C. So this array C contains k elements, and the C is actually subsequence of A. Do everyone understand what do we mean by subsequences? So like for example, A contains 1, 2, 4, 3, 1, and let's suppose I give you the value of k as 3. So one possible subsequence of this is 2, 4, and 1, 2, and 3. This is one of the array C that you can construct. You can even construct 2, 4, 1. You can even construct 2, 4, 3. So these are the 3 length subsequences of array A. So what you are doing is you are given an array A containing n integers. Out of this, you need to construct an array C that is of size k, and the C is a subsequence of A. So the question asks you that what is the maximum value of f of C that you can get? So this f of C contains k elements. So the question is that what is the maximum value of f of C that you can get? So like for example, let's suppose the numbers were 1, 2, 4, 3, 1, and I say you that I give you the value of k as 3. So what are the possible subsequences that you can select? You can select 1, 2, 3, you can select 2, 4, 3, and these are some of the possible subsequences. So if you calculate the f of C for this particular array, so what it will be? It will be 1 plus 2 plus 2 plus 3, which is 8. Similarly, if you calculate for this, it will be 2 plus 4 plus 4 plus 3, which will be basically 7 plus 6, that will be 30. And you can select multiple other subsequences as well of size 3, but you will see that this is the maximum. This is the subsequence that will produce the maximum value of f of C. You will never be able to select any other subsequence that produces f of C greater than 30. So you will say that the maximum value of f of C that you can obtain is 30. So is the question understood to everyone?
Yes.
Okay. So how should we approach this? So just if you observe this thing, if we are having an array of length k, so what are the elements? Like elements are this, like let's suppose C1, C2, C3, C4 up to CK, CK minus 1, and CK. So do everyone agree with me that the value of f of C will be nothing but C1 plus 2 multiplied by C2 plus C3 plus up to CK minus 1 plus CK. Do everyone agree with this, or anyone is having any doubt? The first and the last element will come only single time, and rest all the elements will be added 2 times. And you can see this by looking at this. The first and the last element comes only a single time, and rest all the elements B2, B3, and B4 come twice. Okay. Now, if you understand this thing, that okay, the first and the last element is coming once, and all the remaining elements is coming twice. So what should I do? How should I solve it then? So if I am having something like this, that okay, 1, 2, 3, 4, and 3. I have something like this. Or let me take one more example. I have something like this: 1, 1, 4, and let's suppose I take 3. Okay. Or let's suppose I just take this as 2 and take this as 1. Okay. If I take this and I tell you that this is an array A, I want to construct a subsequence of length 3. Now, what is the first thing that comes to everyone's mind? Let's change this example a bit more so that the things will become clear then. So let's take this as 2 and 3. Okay. So what the first thing that comes to everyone's mind? That okay, take k elements with maximum value. This is one of the things that will come to our mind first. That okay, take k elements with maximum value. Check which is the first element, check which is the last element. Add the first and last element only once and add all the remaining elements twice. So what you can do, you can just maintain a priority queue along with index and just add the first and last element once and the remaining middle elements twice. Okay. So this is something that we can always do. But will that work? Will that work? If I try to do something like that in this particular array. So I will end up taking this particular subsequence 2, 3, and 4. If I calculate value for this, it will be like this. 2. Let's take this as 2. So I will end up with this value 2 plus this is the middle element 2 into 2 4 plus this is the last element 4. So I will get value as 10. But just think if I would have taken a subsequence like this 2 4 1. So in this case the value of function f would have been 2 plus 4 into 2 plus 1 which is 11. So which one is better? Taking k maximum elements or not taking k maximum elements? Which one was better? And why is this happening? That taking k maximum element is not giving is always not giving us the maximum value. This is because of that thing that first and last element is getting added once and all the remaining elements is getting added twice. So that is one thing that is present. So because of that, this is not optimal. That always take first k maximum elements and solve the question. Do everyone understand that why we can't take k maximum elements? Anyone having any doubt in that? Just let me know. No. If you understand this thing, so what my intuition was that, okay, if I have n elements in my array, so every element can be a starting element. Do everyone agree that this element can also be the starting element? This element can be the starting element of the k-length subsequence that I am choosing. This element can be the starting element. This element can be the starting element. Now just tell me one thing. If I tell you that this is a starting element, this is my starting element. So do you have an array? So let me, yeah, you have an array. This element is a starting element. So what you will do? You will choose k minus 1 elements from here. Do everyone agree? You will choose k minus 1 elements from here. Because one element is already chosen from the k-length subsequence. So you will choose k minus 1 elements from here. So if I tell you that choose maximum k minus 1 elements from here. If you are able to choose maximum k minus 1 elements from the right part, now just imagine what can be the cases. So the cases can be that you chose an element at this particular index. Let me take with an example 2, 2, 4, 1. And this is the same example. And let's suppose I tell you that the value of k is 3 and you chose this as the starting index. You chose this as the starting index. So you have one value 2. Now you chose k minus 1 maximum elements from the right. So what are the k minus 1 maximum elements from the right? They are 2 and they are 4. Isn't it? They are 2 and they are 4. And 2 gets added once, 2 gets added twice, and 4 gets added once. So you know that the maximum value that you will be able to produce is 2 plus 4 plus 4, that is 10. But you know that there was a possibility that I don't choose k maximum elements out of which before that I choose any other element. What I mean by that? That let's suppose I tell you that the maximum element over here is 4. Okay, and this was the last element that I was choosing. So there is a possibility, like what is our aim? Our aim is that I will push some maximum element in between instead of keeping it in the corner. instead of keeping some element at the corner, I will try to push this element in between of the k length subsequence so that I am able to add it twice. So what I will do is, from this k minus 1 elements, I will take the minimum value. The minimum value was 2. So what I will tell now is that, okay, I will remove this 2 from here. So the value that I was getting was 10 and 2 was added twice. So I will remove this 2 from here. And instead of adding 2, I will add the maximum element that is present towards the right of 4. Because I want to construct a k length subsequence. Now I want to choose, if this is my starting element, I want k minus 1 elements from the right. So I decided that, okay, let's choose k minus 1 maximum elements. So taking k minus 1 maximum elements, I was able to produce 10. But now there is a possibility that I want some element that is at the end of these k minus 1 elements. I want that particular element to come in between. So the best possibility would be that from this k minus 1 elements that I have chosen, remove the minimum element of this, because I don't want this sum to get affected by too much. So remove the minimum element from this k minus 1 element, remove its contribution, and I want to add the maximum possible contribution. So the last element that I added in k minus 1 elements was 4. So what is the whatever is the maximum element towards the right of 4, simply take that particular element as my last element. So if I do that, so 10 will get 2's contribution will be deleted. 4's contribution, which was the last element, will be added one more time. And the maximum element towards the right of 4 was 1. Let's suppose all values are 1. Maximum element towards the right of 4 was 1. So I added 1 and I was able to get 11. So this is the logic for this question, that, okay, always choose k minus 1 maximum element towards the right. Now there is a possibility that the element that you chose at the last, you want that element to come in between. So what you can do is, you can remove the minimum of the k minus 1 elements you have chosen, because you don't want your sum to get affected by too much. Remove its contribution. And now you want to maximize the sum. Since you want to maximize the sum, so you add the maximum element that is present towards the right of 4. That is the last index that you chose in this k minus 1 elements. Towards the right of that, whatever is the maximum value, you will simply choose that particular value as your maximum element. If you do so, you will be able to produce some answer, and either this will be the maximum one or the first one will be the maximum one. So from these you can take the maximum, and you can do this for every index I that is a probable starting element, and you can output your answer. Is the logic clear what we are trying to do? How we will do that, I will come to that. But is the logic clear that why and how we are doing this thing? You are doing this for every possible starting index.
But what if there is no element after your k minus 1 elements?
So
To the
you will
right.
not do this thing. You will not do this thing. If there is no element after k minus 1 maximum elements, you will not do this thing.
Just a thing. That I was thinking that you can't take the first and the last element in middle, right? You can't choose them.
Yes.
So what I was thinking, if we sort the remaining n minus 2 elements in descending order, and if we take k minus 2 elements from them, and also we take the minimum index and the maximum index among those k minus 2 elements, and see like this will be going to divide the array in 3 segments, right?
Yes.
So if I take the maximum from 0 to the minimum index, and the maximum from uh, a maximum from the maximum index to n, and I will make them my starting and ending points. So this was not working. Can you please explain why?
Need to think that actually. It will
Okay.
take some time. Need to
Okay, we
think on
can
that.
discuss it afterwards.
Yeah. Okay. So is this logic clear that what actually we are trying to do?
Sounds good.
Anyone having any doubt in this? Kindly let me know over there.
Hi Harsh.
I had
Yes,
just
hi.
one doubt that why we are removing that minimum one. Like we already chooses k minus one elements from the right
Yeah.
hand side.
Let's
Then
suppose we have
huh,
two, three, two, four. Okay. And there are elements present three. Let's take this as 50. And let's suppose we have elements one, one, two. Okay. Now let's suppose this is my starting element I chose, and the value of k is 5. So what you will do? You will choose the remaining four elements as 2, 3, 2, and 50. Now, in that case, you will get some answer. Now, if from this k minus, if from this k minus 1 elements, what you want? You want this 50 to go inside, isn't it?
yes,
Because
yes.
this is your k element, you want this 50 to go inside. If you
Okay.
want this 50 to go inside, you will remove some element from here.
Got it, got it.
So you should always
We
remove the minimum element, isn't it? Because you don't want this sum to get uh, too less. You may have even something like this as well, 2, 3, 2, 50, 2. So in this case, you already have 50 inside. So that's not an issue. But yeah, always like you would check both the conditions, that if you are taking the maximum of k minus 1 elements, or you are pushing this element inside and taking a maximum from it. Now again, if you are pushing this element inside, which element you will choose from these three as the last element of your subsequence?
last
Which
element.
one you will choose? This one,
Say,
the maximum.
take it. I just want
This
to ask one thing, like
yes.
how do you come to this intuition? Like what are you said now? I did the same thing and I got the wrong answer for the
Okay.
same solution. Like
Like actually,
when
what
you're
I was
solving it.
thinking is,
Hmm,
yeah,
hmm,
while I was solving it, at start I was even a bit confused, but then I decided that then I saw this thing that I was coming to this. I saw this thing. AI lies between 1 to 50. So I thought that okay, there must be something related to this. That okay, we are given that AI is 1 to 50 only. There must be something related to this only. So what I decided is that okay, whenever I am given questions like this, that choose a subsequence of length k, always one thing that comes to my mind is that there are multiple subsequences. So always I choose some index I, so that all the subsequences ending at this I, or all the subsequences starting from this I. So in this question, what I did is I started with all the subsequences starting at this particular I. So if I am taking a subsequence starting at this particular index, so I know what is my starting element of the k length subsequence. That is something that is very much clear. So now for the remaining k minus 1 elements, always my one intuition would be that take the maximum k minus 1 elements from here. Take that. And this is something that I can easily do. Why? Because if I traverse from right to left and I just maintain that how many times 50 is coming, how many times 49 is coming, how many times 48 is coming, because the maximum value is 50. So at this particular index, I can simply traverse a loop from 50 to 1 and take the maximum of k minus 1 elements. I can simply do that. So take k minus 1 elements. If you take that, so there is a high possibility that you get the maximum element 50 over here as a last element. That is a possibility. So in that case, I would greedily want that I push this 50 inside. That okay, there is some value 48 present over, there is some value 2 present over here, there is some value 3 present over here, and all the values towards the left of 50 are lesser as the values compared to the left of 50. All the values towards the right of 50 are lesser as compared to the values less of 50. That is when I was choosing k minus 1 maximum elements, I got all the elements towards the left of 50 and 50 as my k minus 1 elements. I got that. But in that, I added 50 only once because I chose 50 as my last value. I added 50 only once. But I want to add this 50 twice. Greedily, I want to check that if I add this 50 twice, would I be able to produce a maximum result? So if for adding 50 twice, if I have to sacrifice some values and add some lesser values from the right, there is a possibility that I can get a better answer. Like the example that I took over here, in this, I was able to get a better answer. So that only was my thinking, that okay, sacrifice the minimum value, because if I am sacrificing a value, I would every time sacrifice the minimum value. So sacrifice the minimum value from here and take the best possible value that I can take from the right. So by doing that, just check if I can get a better result. That was my intuition actually.
Hello. Actually, I had a
Yes.
doubt.
Yes.
So during contest, I thought that we would use DP in this problem. Because
Actually, DP was not possible because for every index I, k length subsequence. So this I and k, actually we have to include this if we are solving it via DP. So this is something that is not possible. This is not possible because the value of index and k both are 2 into 10 power 5. So
okay,
you
so
can't construct DP.
is that how you find out that this problem we will not use DP by checking the time complexity?
Yeah, by
Okay.
taking this I and k.
Okay.
Actually I even tried it by DP by looking at the value of AI, but I figured it out that I at least require this I and k for my DP parameters. And again, now looking at the constant, this is not possible via DP.
Okay.
Okay. So now there are 2 to 3 things that I want to do. One thing is to every now there is one more thing. If I tell you that this is the starting element, this is 2, 2, 52. If I tell you that you want to choose 3 elements, if I tell this is index 0, this is index 1, this is index 2, this is index 3, this is index 4. I want to choose 4 elements. Okay, not 3. I want to choose 4 elements. Now I choose that, okay, this is my starting element. Can anyone say me that which of the remaining 3 elements should I choose? Their indexes actually. I want the indexes of numbers that I should choose as the remaining 3 elements.
Second,
1, 3, 4.
1 third, 1, 3, and 4.
Do anyone have any doubt that we will not choose 1, 2, 3? Anyone have any doubt in this? Because we will always try to keep the minimum element towards the back. Agree? Yeah. So if you understand this thing, now I should jump onto the code and I should explain how I have coded this. So first of all, took inputs of n and k, then took inputs of vector, and I have taken input of, I have constructed 2 maps. So what are these 2 maps? So I have 2 maps over here, MP and count I. So this count I, let's count 1 or I took as count I. Don't know why show weird variable name I thought of. Okay, so we have count I. So this count I basically stores that for every number from 50 to 1, how many times this particular number is coming in my map. So how many times number is coming in my map. Because I am going to traverse from right to left and choose every index as my starting element. So for this starting element, towards the right, how many times every number is coming from 50 to 1, that is something that this vector is storing. What is this map is storing? What is this map MP storing? This map is storing for me for every index, for every value, the rightmost index that it is present at. Okay. And you will get to know why I am storing the rightmost index that this is present at. If I try to give a bit of hint, so this is the reason. Because for 2, I want its rightmost index. So that's the index. That's the reason for every element I am storing its rightmost index. So, and one more thing I want, for every index, I also want the maximum value towards its right. Because while I am shifting this particular index, I want its maximum value towards the right. So that's the reason I have also constructed this vector int maxi. So what I am doing is I am traversing from all the elements from n minus 1 to 0 and updating my maxi of I as max of maxi of I plus 1 comma v of I. So this maxi vector is basically a suffix maxi vector. For every index I, it will tell me that what is the maximum value from index I to index n minus 1. Is it clear till now? Do anyone have any doubt till now? Till this point? Okay. So now I initialized my answer to 0. I will simply try to maximize this answer. So what I am doing is I am going to each and every index from n minus 1, index greater than equals to 0, index minus minus. So basically traversing from right to left. If my value of n minus I is greater than equals to k, then only taking this I as my first element, I will be able to construct a k length subsequence. Agree? Minimum length that I need is k. So if only n minus I is greater than equals to k, then only I will be able to construct a k length subsequence. Otherwise, I will not be able to do so. So if this is not the case, the simple step that I am doing is, if I have not found v of I till now, then I am to my map v of I am simply adding I and increasing the frequency of this number v of I. So as basically I told you that count I stores the frequency of every number. So simply increase the frequency of the number. And if I have not added this v of I still now in my map, so simply adding it in my map, because I want to store the rightmost index. So since I'm going from right to left, and if I have added this v of I earlier, so I will not update that, isn't it? So what I did in this step is it clear to everyone?
Yes.
So let's check how we can construct a k-length subsequence now. So now when I am trying to construct k-length subsequence, I know that my starting value is v of I. That is the element present at index I. So I simply stored that in my temp variable. Initialized my count to 0 and my one variable index to I. You will get to know what this index is. Let's ignore this for now. You have these two variables as well. So let me come to this code, and then I will explain what these variables are actually storing. So since I know that I want to take maximum k minus 1 element, so I simply traverse from j equals to 50 to j greater than equals to 1. So traversing from 50 to 1. First of all, I will take all the 50s that are present towards the right, then all the 49s, then all the 48s, then all the 47s, something like that. So is the logic clear why I'm going from j equals to 50 to j greater than equals to 1? Yes.
Yes.
So now if my count, that is the total number of numbers that I have already taken from the right, is already k minus 1, I will simply break. Okay. If I have already completed the request for k minus 1 numbers, I will simply break. And if my frequency of this particular number j is equal to 0, that is, it is not present even a single time towards the right of this particular index I. So I know that I can't take this particular number, so I will simply continue from it. Otherwise, if this is not the case, the total number of numbers that I require from right is k minus 1. And I have already taken count number of numbers. So I require now k minus 1 minus count numbers. And the number of j's that I have is count I of j. So how many of these j I should take? It should be minimum of k minus 1 minus count, comma, whatever I have in my basket. If I have, let's suppose, 2 j's already, but I require only one more element from the right, so I will take only one j, na? I will not take 2 j's. So that's why I am taking the minimum of what I want and what I have. Is it clear till here what this request variable is storing?
Yes.
So what will get added to my answer? So for now, I am assuming that every element I am adding twice. So how many times I am taking this number j? Required number of times. So since I am adding all the numbers twice, I know that the last element will be added only once. We will correct that thing towards the down. But for now, I am just taking that, okay, I am taking all the numbers. Since I take this number j required number of time, and since this j added twice, so to my temp, I simply added 2 into required into j. And to my count, I added required, that I took required number of numbers. And my minimum value becomes j. That is the minimum value that I have taken from this k minus, because I want to maintain that thing. Now, what is the minimum number I am taking from this k minus 1 elements? So for that, I've kept one mini variable. So now you will get the meaning of this mini variable. So this mini variable actually stores the minimum element that we are taking out of those k minus 1 elements. So this mini variable gets updated to j because we are going in descending order only. And this mini index basically stores the index of that j, the index of that variable. So it is mp of j. And this index int actually stores the maximum index that we took. Like if I tell you that I am taking 2 as a first element and I took 3 to 50, let's suppose this value was 1, I took 3 to 50. So if I am trying to shift 50 towards the left, so before trying to do that, I have to know what is the index of 50. I have to know the index of 50. Only if I know the index of 50, then only I will search that, okay, what is the maximum element towards the right of 50? So remove the minimum element and add the maximum element, something like that. So I need to know the last element of the k-1 elements that I am choosing. So the last element I am simply updating in this variable index. So this variable index stores actually the index of the last element that I chose out of the k-1 element. So this index basically gets updated to max of index comma mp of j. So this mp basically stores the rightmost index for this j. So this index gets updated by that. So is everyone clear what we are doing in this for loop? Take approximately 30 seconds and just try to go through this for loop and understand what actually we are doing. Just let me know if any doubt exists or if I have to explain it again. Is it clear?
Here, why are we taking 2 into required into j? Because if the
Because what I am assuming is that for now I am adding all the k-1 elements twice. So if I am taking the element j required number of times, so what will be the sum that it will contribute? J into required into 2.
okay, in the slides, did you use the same method or was it a bit different?
Yeah, the logic was same that that if you have 2 and you are choosing k-1 element, so every element will get added twice except for the last element. We will compensate for this last element later, but for now just assume that every of these k-1 elements is getting added twice. So this is something that I am doing. If we are taking the element j required number of times, so every element will get added twice. So the sum that it will contribute is j into required into 2. The minival is actually the minimum value that we have taken of the k-1 elements. So this minival stores the minimum value that we are taking of k-1 elements, and this mini index is actually the index of that particular value, the rightmost index of that particular value. So that if I explain you why this example, so if my starting element is 2, so and the value of k-1 is the value of k is 4, that is I want to choose 3 elements from the right of this 2. So the value of minival will be 2. That is the minimum of these 3 elements that I chose was 2, and the mini index would be 0, 1, 2, 3, 4. The mini index would be 4. The rightmost index of the minimum value that we chose was 4. This is what mini val and mini index is storing, and this index ind is actually the last element that we are choosing. So in this case, the value of ind will be 2 or 4 only. But if let's suppose this was the case, 2, 3, 2, 51. So in this case, the value of ind would be 3. The last element of the 3 elements that we are choosing is 3. Index of the last element is 3. So this index basically is equals to max of index comma mp of j. Because for every element j in mp of j, we are storing the rightmost element at which it is present. So even if we are taking j even a single time, so we will choose it from its rightmost part because we are choosing j in the decreasing order. So is it clear till now? Yes. So now I know that I have added every element twice, but I know that I have done an error there. Because I know that the last element will be added only once. I know that. And I also know the index of the last element that I have chosen by keeping this ind. So what to do now? From the temp, simply subtract the last index once, because last index only will get added once for my function f calculation and not twice. But I have added it twice always. For every number, I have added it twice. So for correction of overcompensation of the last element, what we do is we simply subtract the last element once. So now do everyone agree that my temp stores the sum of the my temp actually now stores the maximum sum I can get from the k-length subsequence if I am choosing the ith index as my first element and remaining k-1 elements, maximum remaining k-1 elements from its right. If I am doing that, So temp can be the maximum value. Do everyone agree with this? Yes. So what I do is I simply take answer equals to max of answer comma 10. Now the part of now that part comes that while we were doing this, no, 2, 2, 3, 51. So now till now we have chosen this as our k minus 1 element, but now we will try to push this 50 inwards. So remove the minimum of these elements, that is I will remove 2 and add the maximum towards the right of 50. So towards the right of 50 the maximum is 1, so I will add 1. So I am doing that thing over there. So now just tell me one thing. If your mini index is equal to index, do you need to do that? Do you even need to do that? No, because you know that you have chosen k minus 1 maximum elements from the right. So if the minimum of those is the last element that you are choosing, so that is the best possible scenario, no? That is 2, 2, 3, 50, 2, 2, 50. Let's suppose sequence was something like this. 2, 3, 50, 2, 1. Now if I tell you that you want to choose 3 elements towards the right of 2 and you chose these 3 elements. Now if the minimum of all these 3 is the last element that you are choosing, so you can't get a better answer from this. There is no better answer from this. So only if the mini index is not equal to IND, what I do is I simply get in my temp 1, I simply store the maximum value of index plus 1. Maximum value of index plus 1 because index IND is the last element that we chose. So now what I want towards the right of this IND, what is the maximum element? That is something that we decided, na? That towards the right of 50, we will choose the maximum element and add it once. So how we can get that? We already had that maxi vector stored. So I got the maximum element towards the right of this IND that is stored in temp 1. Now if IND plus 1 is not equals to n, as someone was having a doubt that what if we don't have an element towards the right? So only if we have an element towards the right, that is index plus 1 is not equals to n, take answer as max of answer comma. You got the sum temp till now. From that, remove the contribution of this minimum element 2. So how many times it will be removed? 2 times because it is the middle element. So remove its contribution 2 into v of mini index. You can also write 2 into mini val over here or 2 into mini index, both are same. So 2 into mini index plus you will add the element present at index one more time because now it will be a middle element. So it will get added twice. One time it is already added while we were considering k minus 1 element and this was our last element. So now since it becomes the middle element, so it will get added one more time. So you will add v of index one more time and you will add the maximum element towards the right of this index once. So maximum element towards the right of this index is temp 1. So you add temp 1. So this is how what you did is you shifted the last element you chose in the middle and removed the minimum of those k minus 1 elements and added the maximum towards the right of index once and took max with answer. Once you do this, so whatever answer you get at the end is the best possible answer that you can produce. This step is something that I already explained you all, that what we are doing with every index. So this is something how you are solving this question. Just tell me if any doubt exists. Do tell me if any doubt exists over here that what we are doing. We are actually choosing the last element that we chose. We are pushing that element in the middle and taking one element from its right. If while we are trying to push that element in the middle, we are removing the minimum element from those k minus 1 elements and taking the element from the right of index once. This is something that we are doing. Clear, great. So that's all from today's session. I hope everyone enjoyed the session. Just wait a minute. Okay, thank you.